phase change technology out there and highly adopted by many software development teams in different companies around the world. I can envision where all the components that are required to build a typical basic mortgage system are all out there in big data, all the algorithms that you need, and you can combine them in any way. So all the basics of a mortgage system could be pulled from data, put together into make an application, getting a new company to start up in that industry, and then they can decide, this is our special sauce in the mortgage industry. We're going to do things a little differently for these features, or we're going to offer this different product that the other guys don't offer. All those things that all the different software companies do could go into a different a database that then could be all pulled and assembled in a different way. So developers aren't doing mundane tasks of the basics. You know, an interest rate calculation is an interest rate calculation is an interest rate calculation.
And a bunch of different people have done it.
Everybody does it.
Everybody's replicating the same thing, basically.
And they do it efficiently or not efficiently. They do it in different languages. But if you just go out there, pull, and say, I need an interest rate calculation, go get it. Now, if you need that in mortgage, great, you apply it there. If you need it in banking, you apply it there. But the algorithm would be done. So we don't have to redevelop that. We can just pull it. So the development folks and IT teams can focus on building what's unique for a company instead of the mundane stuff.
Right, and I actually expanding on that a little bit. If you think of like where GitHub is today, you know, it's code that's sitting out there. It's code that's sitting out, and they do a good job of sort of directing you to code based upon things that you're looking for. But if you can imagine a world where all of that is normalized, to your point, and I'm writing code, and as I'm writing code, it's looking at the characteristics of the code that I'm writing, and then says, "Oh, to your point, we've got code that's just like what you want. It's
out there
in
the database,
and you know, kind of in a Google stack rank sort of thing. You know, this one, you know, if I want concise code or high performing code or whatever it is, it would stack rank them. Here, 98%. Here's looks like the best choice for you. That's a lot faster than the way developers work today, even just in the open source sort of world. There's much more knowledge contained, you know, in our normalized version of the code, and that can be leveraged significantly. And to your point of sort of reuse of code, if you will, or you know, development of new code using code that's already been developed, and we can also, you know, we could take code that's in COBOL, for instance, and normalize it, and then have that code compiled over into Java if we wanted it as well, and use it there, or you know, any language. So that's extremely powerful. So we're really talking about kind of all code being data and all code being utilized,
right?
Which is pretty remarkable.
You know, one key difference about what we're talking about that we've mentioned here is that with GitHub, you go out and you look, and you're trying to find something that you're looking for. With intelligence assistance and big data, it's helping you look. It's doing the looking for you. It's saying, are you going this way? Are you going that way? Which is a big difference as opposed to having to, that's the normalization key. Yeah. Because what happens is you're typing in what you're doing, you normalize it here, and then you go out to GitHub to see if something seems to match what you're thinking about, and you have to analyze that.
And this is actually matching the two.
This is, it's doing it for you. Yeah.